Okay, next, solve and graph the inequality. Well, for me to put into context what you're trying to figure out, you're trying to figure out all possible numbers for x in this inequality. So what I've done is I copied that to a green piece of paper. You don't need to write it, just watch. Maybe -4. Why don't I just randomly put that in for x? So 7, why'd you pick -4? I don't know. Plus 6. -4 plus 6 is 2. Is 2 between 7 and 12? No, it is not. Okay? So -4 is not a solution to that inequality. Now I'm going to put 3 in for x. 3 plus 6 would be 9. Is 9 between 7 and 12? Yes. 3 is a solution. Now I put 4 in for x. 4 plus 6 is 10. Is 10 between 7 and 12? Yes, it is. Yes, 4 is a solution. How about 6? 6 plus 6 is 12. Now 12 isn't between them, it's equal to one of the values, but the equals to sign is there, so yes, 6 is a solution. Well, what I'm trying to figure out is where do the solutions begin and end? That's what happens when you try to find an inequality, okay? Sometimes the end is infinite, sometimes it's not, as you're about to see here. Now, when you have two inequality signs, they don't have to be different, okay, they're the same. You're going to make a table, and your number line is going to go right there. Here's what I put on each side of the table. First, you're going to make overlapping circles. First, 7 less than or equal to x plus 6 on that side. Then make an overlapping circle, and on that side we'll put x plus 6 less than or equal to 12. Now solve each one separately. Remember, you're over here. Get rid of the plus 6, minus 6, minus 6. Line up your inequality. You got 1 and then x. By the way, you can put a 1 in front of the x if you want. Now, normally it would be the time to divide. Is that negative? Is this number here negative or positive? It's positive, so don't switch the sign because you're about to divide by a positive. So here, x is over here. And then 1. You guys have got to switch that around. To graph it on a number line, you need the x to come first and the 1 to come second, and then the sign flips. I should always see the x first, number second. Okay, then over here, get your plus 6 to a 0, you can put a 1 there. Now normally it would be the time to divide. I have a positive number, the sign will not switch. And if it's a 1, I don't even need to divide, okay? Now, put those on the same number line. You put 1 and 6, both positive. So circles would both get filled in because you have equals 2 bars on both of them. Greater than 1, less than 6. Well, they're going to combine. Okay, now on that, write the answer, okay? That's between. So you put 2 less than or equal to signs, equals because the bars are there with x, 1, and 6. That's where I want it. That's what I want to see, the number line and the solution above it. Next up, again, it's a compound inequality because there's 2. On one side, you're going to put -3 is less than or equal to x minus 4. On the other side, you're going to put x minus 4 less than -1. This is where we're at, okay? Put a 1 in front of the x, so plus 4, plus 4. Line up the sign. 1 is here, 1x is here. Now, before I divide, I'm going to circle what's in front of the x. It's a 1. It's positive, so I don't need to change the sign. That sign is going to go the same direction for now, okay, after I divide. So you got 1 and then x. Rewrite that so the x comes first, then the 1. When you're dividing, you really got to see if that multiplier in front of the x is negative or positive. If it's positive, from here to here, you leave the sign alone. If it's negative, it turns around. Now, it turns around here because it wasn't in the order I wanted. Okay, then right here, plus 4, plus 4. That's 3, 1x. Now is the time when I'd normally divide. We have a positive 1 in front of the x, so that sign does not turn on the division. I'm dividing both sides by a positive, not a negative, so the sign stays the same. You got x, 3. By the way, put a line there. I shouldn't have 1, but not the other. Okay. So you got 3. 1 and 3 are your boundaries. And you put circles above both. Greater than 1, less than 3. Just combine them. So you got just 1x listed, less than or equal, and you put 1 and 3. Okay, next up, I want to make that 3 a negative. Change the problem a little bit. Okay, make overlapping circles because you're going to use that table. So negative 10 less than negative 3x plus 8, and then negative 3x plus 8 less than 41. Here's where the x is at. Get your 8 out of there. Line that up. Don't ever turn the sign when you're adding and subtracting. Don't ever do that. Negative 3x. Now it's time to divide, okay? The number that I'm going to divide by is a negative. Turn the sign around. So here I got x, here I've got positive 6. Now that's not in the right order, so then I'm going to switch it. There we are. And minus 8, minus 8. Okay, 33. Now it's time to divide. Look at the number that we're going to divide by. Okay, we're going to put under there, negative 3. That's a negative. You've got to change the sign. When it's dividing time, if you have a positive, if you're going to divide by a positive, because that's in front of the x, you don't switch it. Negative, you do. Negative 11. Okay. So I've got 6 on one side, negative 11 on the other. Circle and circle. Neither one of them have the bar. I'm not going to fill it in. So you're less than 6, but greater than negative 11. So just combine them. Now you just put a single x there with double less than. Negative 11, 6. Okay, next up. Again, you're trying to find all the numbers we can have in the solution set. It's every number between here and there. Okay, that would be a yes, like that is. Okay, negative 1 less than 3x minus 4. Then overlap it. 3x minus 4 less than 14. There's a sign right there. Operate from over here. You got to get the minus 4 to a 0. Line that up. Don't turn the sign when you're adding and subtracting. That's 3. Now I'm about to divide that number in front of the x. It's about that number. I don't care about that one. If that one is negative, the sign switches. But guess what? It's not, so we're going to keep it the same. Then I go divide. So that's 1 and that's x. That's not in the order we use to graph, though. I want to write it as x with 1 greater than. Don't ever graph when it looks like that. Plus 4, it's going to be 18. Now it's time to divide. line up the equal, line it, excuse me. By the way, when it's dividing time, the number in front of x is positive, okay? So the sign does not turn. You got to watch that when you divide. You got x, you got 6. 1 and 6 are the boundaries. You will not fill in either circle. Okay, you're greater than 1, you're less than 6. Okay, when they collide like that, you make a single inequality with x. Double less than 1 and 6. Okay, you got to watch the sign flipping on the division. If the number in front of the x is negative, then switch the darn thing before you divide. If it's positive, you don't. Okay, now we have more compound inequalities with OR statements. 4x minus 3 is greater than 11. 4x minus 3 less than or equal to negative 11. Okay, make your table. You just put that on one side. You don't have to do the overlapping circles here. You will need to make your number line. Add the 3. Remember, sign's not going to turn. After every step, you got to ask yourself, would the sign turn? Never does when you add or subtract. 14, 4x. Now I'm about to divide. When I multiply or divide, you got to look at the number with the x. It's positive, so drop that sign down, same. Divide by 4. It's going to be x, 3.5. Plus 3, plus 3. I'm just adding and I'm just adding so it doesn't turn. Now it's dividing time. We have a positive right there. So the sign will stay the same. That's the number I go off of, the number with the x before I divide, the number that's multiplied by x before I divide. Also, you could also say those numbers I'm putting under the lines, are they positive or negative? If they're positive, it's not going to switch. If they're negative, they will. So x, negative 2. Okay, so 3.5 is on one side, negative 2 is on the other. So I put circles. God darn it, I did that again. Put an equals there. So I want fill them in. That's greater than. That's less than. Okay, so it's an OR statement. Okay, on one of them you put x on each one. And just put what you ended up with. You're greater than or equal to 3.5. You're less than or equal to negative 2. Okay, next one. 7 minus x less than 1. 4x less than or equal to 12. Okay, here's where the x is. Put a 1 in front when it has a minus sign. Okay. You get that 7 to a 0 by subtracting 7. Line up the sign. You got negative 1x and negative 6. Now it's dividing time, and that number be a negative. So switch the sign and then divide. 6. Okay. That's in the order I want. Notice how these are in the exact order I want. I switch the signs in two scenarios. When I'm about to divide by a negative number, those are negatives, flip it, or when it's out of order, but that's not out of order. Okay, now right here, I don't have to add or subtract. I'm ready to go right to division, but now if I'm about to divide, circle that number in front of the x. It's positive, the sign will not flip. Okay, so x less than or equal to 3. Graph. Okay. So put 6 and put 3. 6 is going to be an empty circle. Okay. And 3 is going to be a full circle. Greater than 6, less than 3. So put or between them, and you put x and x. So greater than 6, less than or equal to 3. Okay, 3x plus 2 is less than negative 7, or negative 4x plus 5 less than 1. Okay, this side you got 3x plus 2 less than negative 7. This side, negative 4x plus 5 less than 1. Remember, we're trying to get to the number line. Minus 2, minus 2. Sign never turns when you're adding or subtracting. That's negative 9, and that's 3x. Dividing time, that is a positive. I don't care about that one. It's the number, the coefficient in front of the x. Okay, it's positive. Don't turn it. So you got x and negative 3. Minus 5. It's going to be negative 4. Dividing time, circle that, turn it, okay? Divide by negative 4. X, 1, okay? So, negative 3 and 1. Negative 3 goes that way. 1 that way. So again, it's or again. They don't collide, so I don't put the double less than. I just write what I see. X is less than negative 3, or x greater than 1. So I want to see the number line and also the things written above the lines that you draw. Okay, next one, same idea. Negative 2x plus 7 less than 1. 4x plus 3 less than or equal to negative 5. Minus 7, minus 7. Line that sign up. And it's dividing time. I'm yelling that, so you look at the number in front of the x. That's the number we divide by. It's negative. Flip the sign. Negative 2, negative 2. So you got x and 3. So 4x, negative 8. Dividing time, but that's a positive, so the sign will not turn. It goes the same way. Negative 2. Okay, so 3 on one side, negative 2 on the other. So 3, circle, don't fill it in, goes this way. Negative 2, circle. You are going to fill that one in. And then you put the phrase or, and you're going to put x on each one. Okay? Greater than 3, because you're going that way. Circle's not filled, so I don't put the symbol. And then less than or equal to negative 2. That's how you solve it. Those are the possible values for x.